Imagine a world where you had to replace your light bulb every few hours. That was the reality in the early days of incandescent bulbs. Surprising, isn't it? These glowing orbs of light that we take for granted today had quite a humble and inconvenient beginning. Now they light up our world for months on end. So what changed? How did we get here? This is the fascinating journey of the incandescent bulb's evolution. So, how do we go from a fragile filament to a long-lasting source of light? Let's illuminate this topic. The heart of an incandescent bulb is its filament, made from a metal known as tungsten. Tungsten is chosen for its high melting point and durability, but transforming it into a delicate filament is no easy task. It starts with refining the tungsten into a pure form, removing any impurities that might affect its performance. Then comes the process of drawing it out into a wire. This isn't your everyday wire though. We're talking about a wire so thin it's about the 10th the thickness of a human hair. This requires a level of precision that's nothing short of remarkable. The wire must be uniform in thickness and free of any kinks or breaks. The wire is then coiled tightly, a process that needs to be executed with absolute precision to ensure the filament will heat evenly when electricity is applied. It's a meticulous process, but one that's crucial to the success of the bulb. Once we have our filament, it's time to give it a home. The filament needs a protective environment to shine, and that's where the bulb comes in. The process of making the glass bulb is a delicate one. It begins with a molten blob of glass placed on the end of a blowpipe. The glass is then blown into a mold, which shapes it into the familiar bulbous form we all know. Once it's cooled down, the top of the bulb is cut off to create an opening for the filament. This isn't just any ordinary glass, mind you. It's lead glass, which is incredibly strong and can withstand the high temperatures produced by the filament. Now on to the next step, filling the bulb with an inert gas. But why do we need gas in a bulb, you might ask? Well, the gas helps to prolong the life of the filament. When the filament heats up, it starts to evaporate. The gas molecules bounce these evaporating atoms back onto the filament, preventing it from burning out too quickly. Typically, a blend of argon and nitrogen is used. These gases are chosen because they are unreactive and do not interfere with the light produced by the filament. Finally, it's time to insert the filament into the bulb. This is done by attaching the coiled tungsten filament to two stiff wires, which are then sealed into the base of the bulb. This assembly is known as the lamp mount. The filament is positioned in the center of the bulb, ready to glow brightly when electricity passes through it. At this stage, you might be wondering about the role of each component. Well, the filament is the heart of the bulb, emitting light when heated. The glass bulb provides a protective shell, preventing the filament from being damaged by external elements. And the gas? It's the unsung hero, working tirelessly to extend the life of the filament. Now that all parts are in place, it's time to bring our bulb to life. The final steps in the making of an incandescent bulb are sealing and testing. Once the filament, glass and gas are assembled, we move on to the sealing stage. The bulb is sealed using a process known as tipping. In this process, the glass bulb is heated to a high temperature, causing it to soften. Then the open end of the bulb is pressed together to create a seal. This seal ensures that the gas inside the bulb remains intact, offering the filament a controlled environment to glow. Next, we attach the base, which is typically made of aluminum or brass. The base is the part that screws into your light fixture and forms the electrical connection. It's attached using a special cement that's both durable and heat resistant. Now on to the testing phase. Each bulb undergoes rigorous testing to ensure its performance and safety. This includes tests for brightness, power consumption, and lifespan. It also includes safety checks to ensure the bulb can withstand the heat it generates without shattering or causing a fire hazard. Finally, the bulb is packaged and ready for distribution. Each bulb is carefully packaged to prevent damage during transportation. And just like that, the incandescent bulb, with its warm, inviting glow, is ready to light up your spaces. And there you have it, a journey from tungsten to a fully functional incandescent bulb.